Hello everyone, welcome back to my channel Learning Math with Shelly. Today's topic is repeated decimals. So the first step of this video is understanding what are repeating decimal numbers. Repeating decimals or repeating decimal numbers are those numbers which has a decimal part, but there is something special about those decimal numbers. They contain a sequence of digits that is infinitely repeating and non-zero. Basically, we are talking about recurring decimals. Reoccurring decimals. So, repeated decimals or recurring decimals, they have the same meaning. These are the decimal numbers. So, I give you two examples and I will try to differentiate them. Which one is a recurring decimals and which one is not. So I am taking two numbers here. One is 2.4 and the another I am taking an example as 2.444 and going on. So here, as per the definition, they said it has a decimal part. From here, this 2.4 has a decimal part and 2.444, this is also having a decimal point. They both have a decimal part. But for recurring decimals, they said the decimal part that consists of the sequence of digits. It's not just one digit or two digits. It contains a sequence of digits. And what is the characteristics about the sequence of those digits? That should be infinitely repeating. So if I read up to this point only, infinitely repeating. So in my first example, I said it's 2.4. First thing, it has a decimal part which is having 4. It is a sequence of digit. It has one digit only, but it is not infinitely repeating. It just stopped at 4. Okay. Other than that, on the other side, if I look at the second number, which is 2.444 ... So this is infinitely repeating because I have put the dots here. That means it's an ongoing number. The decimal part is ongoing and this is not zero, right? So recurring decimal means those numbers which has the decimal part which is repeatedly ongoing, or you can say infinitely repeating, and it is non-zero. So this is all about the definition of repeating decimals or recurring decimals. Now the good thing about the recurring decimals is we can convert them into fractions. So we will be learning about that process, but before learning that process, I want to show you some representations of recurring decimals. So recurring decimals, here I am taking the first example as 0.3 dot. The dot was missing, so I am putting a dot here. So it is 0.3 dot. What this dot on the top of this digit 3 is shown here, its meaning is 0. That this 3 is basically repeating, infinitely repeating. So I can write it like 0.3333 and so on. So there are two ways to represent the recurring decimals. First is you can write it as like all the numbers with including dot at the end, or you can write it in a short form which is like 0. Whichever digit is repeating or the digits are repeating, you have to put a dot on the top of them. Second example is 0.36 and there is a dot on both the digits 3 and 6. Now if I write 0.36 and I am writing 0.36 and with a dot on each of them, they are different. Here this is a decimal number, but its digit, the decimal part is not infinitely repeating. It has only two digits. While on the other side, if I look at the number 0.36 with two dots on the top, so this number is 0.36, again 36, 36, and it keeps going like this way. Okay. Then a very important question like 0.3.61. So how we have to write this number? This number means the number is repeating starting from the digit 3 until the digit 1. We will not say it like it is 0.361 then say 3131. No, that will be wrong. It has to be interpreted as the digits are going to repeat it from 3 all the way to 1. Okay, so we can write it like 0.361, 361, 361 and so on. This is a very important point when you will be solving the questions like the recurring decimals into the fractions. We need to understand the representation of these decimals when they are representing with this dot form on the top of the digits, and how to write them in a simple form with the dots at the end like an infinite form representation. I hope the definition of recurring decimals and their representation is clear to you. In my next session about the same topic, I will be discussing how to convert these recurring decimals into the fractional form. Okay, thank you so much.